To solve our first example on kinetic theory of gases, we have this question and it says, calculate the root mean square speed of the molecule of hydrogen gas at standard temperature and pressure, assuming the density of hydrogen is 9 times 10 to the power 2 kilogram per meters cube. Looking at this problem, we are to solve for or calculate the root mean square speed, or I can use the term root mean square velocity. The examples or expressions we can use to estimate that, and here we are told that hydrogen density is given here and that the speed of the molecule is to be estimated at STP. Before I go into solving of the problem, I want us to understand that at STP, volume is a constant, pressure is a constant, and temperature is a constant. So that constant is fixed. So at STP, we should be able to know the value of pressure, temperature, and volume. Let's move down. Solution. Okay, so expression for the root mean square speed of velocity is as follows. I decided to list these three expressions. We can use any of them depending on what we are being given in the equation. So I decided to use these three so that the viewers can look at the expression and memorize them. Then whichever one is suitable to solve a particular problem at a particular time, you can make use of it. So this is the velocity for root mean square, and this is equals to the square root of 3p all over rho. The p here signifies the pressure of the molecule. The density of the hydrogen molecule is the one below here, and this one is root 3 kt over m. So the k you've seen here represents the Boltzmann constant. The t here represents temperature of the molecule, and the small m here represents the mass of individual molecule of the gas. And we also have root 3 RT over m. So the R here represents the universal molecular gas constant. We still have temperature here and then the molar mass of the substance. In this case, if we go back to the equation, they gave us density. Which of this expression is suitable to apply? You see, the first one here has density. Others do not have density. And of course, I want us to know that at STP, pressure, volume, and temperature are fixed. They are constant. Okay, let's move forward. So we have to find the velocity. The density is given. And at STP, these are the constants. Pressure equals to 1.01 times 10 to the power 5 Pascal, or you can use Newton per meter square, whichever is correct. Then the volume is 22.4 times 10 to the power minus 3 meters cube, or in liters, 22.4 liters, of which if you convert it from liters, you get in meters cube. You get the value in meters cube. Then temperature at STP, 0 degrees Celsius, is 273. Okay, so with this, we are not going to use the volume and the temperature, but I just decided to bring it up so that in case you see a similar problem, you should know that these other parameters are fixed. We are only going to use the pressure because from the expression, we have pressure and density. They gave us density, but the pressure wasn't given. So it's left for the student to memorize these values and then you apply them at the right time. Okay? So we choose an expression. We decide to go with this 3p over rho, root 3p over rho. We know the value of pressure, we know the value of density. When we substitute accordingly and then we simplify the following expression, then we will have 18.35 meters per second. Thank you very much for watching. Please subscribe to our channel if you have not yet done that, and if you have done that, thank you for doing that. You can as well give us a thumbs up and then share our video. I really appreciate you. Have a wonderful day.